Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Br2 reacts in the dark at room temperature via ionic, electrophilic mechanisms, not radical mechanisms. Key reactions that proceed without light or heat are 1. Electrophilic addition to alkenes and alkynes, Br2 adds across the pi bond, and 2. Electrophilic aromatic substitution on highly activated aromatic rings, those with strongly activating groups like O, which can react with Br2 without a Lewis acid catalyst. Moving on to the next step. A. Benzene aromatic ring with no activating substituent. Electrophilic aromatic substitution with Br2 requires a Lewis acid catalyst, Fe-Br3. Does not react with Br2 in the dark at room temperature without catalyst. B. Cyclohexene contains AC is equal to C double bond. Br2 undergoes electrophilic addition across the double bond in the dark at room temperature, bromine water CCl4 test for unsaturation. Reacts. C. Cyclohexane, saturated hydrocarbon. Reacts with Br2 only via free radical halogenation, which requires UV light or heat. Does not react in the dark. D. Propanoic acid, C2H5CO2H carboxylic acid. The alpha halogenation, Helmholtz-Zielinski, requires red phosphorus and Br2, not just Br2 alone at room temperature in dark. Does not react under these conditions. E. Phenol, C6H5 of the hydroxyl group is a very strong activating, ortho-para-directing group. It activates the ring so strongly that phenol reacts with Br2 water immediately in the dark at room temperature without any catalyst, giving 2,4,6-tribromophenol. Reacts. F. Nitrobenzene, C6H5 no to the nitro group is a strong deactivating group. Even electrophilic aromatic substitution requires harsh conditions, fuming H2SO4, high temperature. Does not react with Br2 in the dark at room temperature. G. Hexine, C6H10 contains a CC triple bond. While alkynes do react with Br2 by electrophilic addition, they are generally less reactive than alkenes toward electrophilic addition because the sp hybridized carbons hold the pi electrons more tightly. However, hexine, a terminal or internal alkyne, can still add Br2, but the question's answer does not include G. The answer provided excludes hexine, suggesting that under the specific conditions stated, room temperature, dark, the reactivity of the alkyne is considered insufficient or the question specifically focuses on the most reactive cases. Alternatively, some sources note that internal alkynes react more slowly. Given the provided answer is B and E only, hexine is excluded. H2,2-dichloropropane, C3H6Cl2 saturated haloalkane. No pi bonds, no activated aromatic ring. Would require radical conditions, light, for further halogenation. Does not react with Br2 in the dark at room temperature. And for the final step, only cyclohexene, B, reacts via electrophilic addition and phenol, E, reacts via electrophilic aromatic substitution without requiring light, heat, or a catalyst. Therefore, the correct answer is B, E. The correct answer is shown on screen.